basically, when we are doing this, we need to have our notes out. Let me go find this. I think I might be losing my mind today. Alright, so when we are doing this problem, we need to have our notes out because we don't remember all these rules off the top of our head yet, correct? Yes and no. Huh. Okay, moving on. The first one, let's look at this equation. First of all, our energy is on the left side, right? So that means it's what? Endothermic, that's going to come in handy later. We have a gas and a gas forming a gas. We have 2 moles on the left and how many on the right? 2 moles on the right. Okay, so now let's start answering this question. So number 1 is with us, so adding H2, so that means we're adding a reactant, correct? So when we add a reactant, if we look back at our notes, it says adding chemicals to the reaction will shift it away from that side. So if we're adding reactants, it's going to shift it to the right, okay, which is exactly what they said. So if we are adding H2, this should decrease, and our product should increase because it's shifting away, which means our products should start to increase. Okay, our K remains the same. K only changes when we change temperature. Okay, so now let's look at adding I2. Again, we're adding a reactant. When we add a reactant, it causes the equilibrium to shift away. So in this way, since we're adding a reactant, it's going to shift towards the products, which means hydrogen is going to decrease, while HI is going to increase. What's going to happen to K? Stay the same. Number 3, this time we're adding HI, which is the product. When you add something, it shifts it in the opposite direction. So if we're adding products, it's going to shift towards the left because we're shifting towards reactants, which means our reactant should increase. What's going to happen to our K? Stay the same. Okay, this time around we are removing. 4, 5, and 6 talk about removing. So let's look back at our notes and let's make sure we remember the rules. For removing chemicals, if you remove chemicals in the reaction, you will shift the reaction towards that side. Okay? Alright, so remove H2. So if we are removing a reactant, it's going to shift towards the left because it's going to shift towards the reactant. Which means our reactants are going to increase while our product decreases. What's going to happen to our K? Stay the same. Okay, if we remove another reactant, it's going to shift our equilibrium towards the left, which is going to do what to our reactant? Increase it. What's going to happen to our products? Decrease. What about our K? Stay the same. Okay, if we remove some of our product, it's going to shift the reaction towards the right. What's going to happen to our reactants? Decrease. What's going to happen to our K? Stay the same. Now we're talking about temperature. Number 7 and number 8 are talking about temperature, right? So let's look back at our notes and let's review temperature. In temperature, when heat is added to a system, the reaction will shift away from the side of the equation where the energy is. Okay? We've already determined this is an endothermic reaction, right? So therefore, increasing the temperature will shift the reaction towards the right, towards the products. So if we increase our temperature, it is going to shift it where? Okay, we're adding additional energy over here, right? Kind of, yes. Yes. So what's going to happen to our reactants? They're going to go down. What's going to happen to our product? It's going to go up. What's going to happen to our K? Go up. Now, another way to think about this, honestly, when you're answering the temperature equations, it kind of makes sense a little bit. When your temperature increases, doesn't your reaction usually happen faster? Your reaction is happening faster, doesn't your product usually form faster, right? For instance, if you're cooking dinner and you turn your pan on hot, you might burn the outside of your chicken before you actually cook it all, right? You want to cook slowly, right? All right. So what happens if you decrease the temperature? So we're taking away some of our reactant technically, right? It's going to shift to the left, which means our product is not going to form quite as fast, right? So that's going to increase our reactants, decrease our product, and it's going to decrease our K. I kind of like what Caitlin said. It's kind of like you're adding or taking away reactants. So. All right, number 9 and 10 are talking about pressure. So what do you think I'm going to do? Before I do that, I'm going to look back at my notes, make sure I remember the rule, because we don't know these all the way yet, correct? All right, pressure shifts. When pressure is increased, the reaction will shift towards the side of the reaction with the least number of moles of a gas, right? When pressure is decreased, the reaction will shift towards the side of the reaction with the most number of moles of gas. Casey has a very good point. What's wrong here? We have 2 moles on the left. We have 2 moles on the right. So is anything going to happen? Everything is going to stay the same because there is no shifting going to happen because we have 2 moles versus 2 moles. All right, let's look at the bottom one. Okay, we have sodium hydroxide solid, forming sodium plus hydroxide plus energy on the right. So right off the bat, let's identify this type of reaction. Exothermic, our energy is coming out of the reaction. Pure solids and liquids do not affect the equilibrium values. Okay, so when we get down here, this solid is going to have a little bit of a factor, right? Okay, so we are going to add more product. Let's try to do this without looking at our notes. When we add more product, what happens? It should shift towards the right, which means our products are going to increase. Okay, and if you remember, pure solids are not going to affect our equilibrium values. So honestly, K equilibrium is going to equal the concentration of our sodium times our concentration of our hydroxide, right? And nothing on the bottom. So if our sodium and our hydroxide is getting bigger, what's going to happen to our K? It's going to get bigger. Because we have nothing to counteract it on the bottom, right? Correct. Because solids don't go into play with K equilibrium. So therefore, if our concentration's on the right, gas. Or aqueous. Liquids and solids don't play. All right, adding sodium chloride. Okay, adding sodium chloride onto we're going to increase our sodium, so it's going to, we're adding a product, right? So it's going to shift it towards the reactants. So our sodium hydroxide is going to increase, while our hydroxide is going to decrease. So our K equilibrium should probably decrease. Remember, there's nothing on the denominator here. So what happens to these concentrations is going to change our Ks. Okay, up here, our equilibrium constant was this divided by this and this. So as one side decreased, the other side increased, it probably did it at the same rate. Down here, there is no, if one's increasing, it's increasing. If one's decreasing, it's decreasing, because this is not in our equation. Good. No, when you add a product, it shifts it in the opposite direction. So since we added sodium, a product, it's going to shift it towards the sodium hydroxide, which means this number is getting smaller. If this number gets smaller, so does our K. Alright, so now we're going to add hydroxide. So again, we are adding a product which is going to shift it towards the left, which means our sodium hydroxide is going to increase while our sodium decreases. If our sodium decreases, our K should decrease. Okay, adding hydrogen is basically taking away hydroxide, so we're removing a product. When we remove a product, it shifts towards it. So our sodium hydroxide is going to decrease while our sodium increases, which is going to cause our K to increase. Okay, temperature. We've already established this is endothermic, right? Okay, so in an endothermic, this one we're a little fuzzy on still. And for an endothermic reaction, increasing temperature will shift the reaction towards the product. So this is endothermic. So if we increase the temperature, it's going to shift it towards the... Okay. So therefore, what's going to happen to our sodium hydroxide? Decrease while our sodium and our hydroxide, which is going to cause our K2. Okay, if we decrease the temperature, the opposite should happen, right? So what's going to happen? Left. Oh wait, did I look up the wrong one? I looked up the wrong one. Sorry. I was still on the other one. We're not endothermic, we're exothermic. Just stacking that. Sorry. I just read the wrong one. I'm sorry. For an exothermic reaction, your increased temperature is going to shift it towards the reactant, so I'm sorry. It's early for me. Okay, so now decreasing the temperature will make it do the opposite, right? So that means this is going to go down while this goes up, while this goes up. If our concentration of our products goes up, our K should go up. Alright, so now we need to review pressure. Those are the ones we're still a little foggy on, right? Temperature and pressure, a little foggy. Pressure. We are going to increase the pressure. We need to count the number of moles, right? So let's see here. Oh, wait. There is no gases. Is pressure going to change anything? Well, aqueous is technically in liquid form, and liquids don't compress with pressure changes like gases do. Like, say I have a water bottle and it's full. If I